Hello, welcome to Heavy Wireless. My name is Keith Parsons, and in this week's episode, we have a special topic, and today's topic is on building sustainable and highly efficient backhaul and routing networks. And we've got some special guests who will help explain that topic to us. And again, today is a sponsored episode with Ceragon Networks. And I have with me Danny and Erez. Danny, can you give us a quick overview, a little elevator pitch, if you will, of what is Ceragon Networks?
So Ceragon is one of the known companies in the world, I would say, in transport solutions. So transport is our expertise, and we have an emphasis on point-to-point wireless backhaul and open routing. Our customers are mostly service providers of all sizes, from large mobile operators all the way to small and medium ISPs and wireless ISPs. We also provide solutions to private networks in different verticals, things like utilities, energy companies, government defense, public safety, those kind of private networks. And what we do for our customers in a nutshell is we help them deliver connectivity everywhere they need it, even in the most challenging environments and geographies. We help them connect between their access networks and their core networks. And our products and services are based on our own innovative technology. We develop in-house our chipsets, and we've been doing that for almost 3 decades. And maybe last thing to say is that our team is spread globally because our customers are spread globally. So we have more than 1,000 people, skilled professionals all over the world.
Very good. One of the terms you used in your elevator pitch was backhaul. What kind of challenges do your customers find with backhaul? You mentioned some very, unique, difficult challenges. Can you tell us some of those?
So talking about backhauling is more or less after the radio access network, when you are just picking up your cell phone and just trying to talk what's really happening in the background. And you need in the end to gather all the information and move it towards the internet, toward the core. And this is exactly where the problem starts and all the challenges starts. And this is where Ceragon trying to solve it. We're talking about all the transport in between the end user, in between the radio access up until to the core. And speaking of challenges, it can be huge amount of them. We'll start maybe with everything that's related to the 5G. In the past few years, the 5G is rising, and with this rise, there are a lot of services that comes with the 5G and which requires the operators, so it requires a much more, I would say, different services. And the first one of them is the enhanced mobile broadband that needed. So you need to deal with huge amount of capacity. You need to deal with much lower latency. You need to deal with much more customers and much more connected people, and all of it over the same physical network. And to overcome these challenges, there are plenty of things that you need to do. So it comes that now all the operators trying to put fibers everywhere that they can do it, but it's not always that you can do it.
So your solution is a complement to fiber, or is it a replacement for fiber?
It can be both. So we can complement it. So from the point that there is no point of presence to the fiber, and still you have a distance to go towards your consumer, towards the customers, then you will use the wireless. But also, if you want to have a redundancy to the fiber, or you want to not invest that much in the fibers at the first glance, or then you will use the wireless. And this is how the wireless transport really helps operators to take much more customers, because the time to market to connect an area, a city, a place to the internet with wireless transport is like 10 times more efficient than going and digging and putting fibers and then to do the connectivity. You just need to raise an antenna and a wireless radio, and that's it. You are connected. And we can do it like from 1, 2, 3, 4 kilometers up to 250 kilometers to connect areas. And this is exactly what Danny said. We can connect everything everywhere, no matter what is the terrain, what is the distance. And this is more or less what we're doing in the past 25 years.
Very good. So when you're putting up these radio networks to connect cell towers together, you said 10 times faster than a fiber dig. What would a normal install be if you just needed a point-to-point, say, 10 kilometers apart?
Well,
how many days would that take?
I would say that in average is like day or two, and sometimes it can be like even less than a day, assuming that you have all the equipment with you and you have the authorization to put antennas. Then a point-to-point microwave link or millimeter wave link can be like within less than a day. And if you have an experienced and very trained engineers that can do the installation, you can even put several cell sites within a day. So comparing to digging fibers, it can take like a month or 2 weeks, or I don't know. It really depends on the terrain and everything. But the main thing about wireless is the flexibility. So first of all, you can just connect this area as soon as you can, give these people the connectivity. While the fiber will be there, you can just uninstall your wireless equipment and then move it to the next place. So operator has the flexibility even to start with the wireless and then take it, shift it to another place and another one. But in this time, they are getting time of market.
Great. I appreciate that. Our audience is very much wireless focused. They understand RF and spectrum and frequencies. What frequencies and protocols are you running on your backhaul wireless that you're using?
I would say that up until a few years back, I would say maybe up until 10 years back, all the industry was speaking about the traditional microwave, which is in between 6 to 42 gigahertz. This is the license band. And in the past few years, we saw the rise of the millimeter wave, the rise of the E-band. I'm putting the V-band and the unlicensed aside. We're talking about the double-digit E-band growth over the years, and the millimeter wave in between 71 to 86 gigahertz. This is key growth engine for the wireless market. So if I'm accumulate everything is in between 6 gigahertz up until 86 gigahertz. This is with the E-band. And then he mentioned that we're doing our ASIC in-house. So everything that we're doing right now, we are looking ahead, like within 2, 3, 4 years ahead. And we are also working about the W and the D band, which is up to the 170 gigahertz spectrum. For this boat, we already have in place like the demo platform. So W band will come in the coming 2 years, and right afterwards the D band, which allow us to, in the end, to reach to 100 gig over the air. This is our target.
So Ceragon's involved in the transport network. What kind of steps do you need to take to make sure that's as efficient as possible?
Erez mentioned several challenges that the service providers are facing when laying out their transports, specifically wireless transport. And really the key to build and operate a highly efficient transport network relies in what we call open transport concept, which brings together two domains, the wireless transport on one hand and the IP transport on the other hand. It really gives the answer, to the network densification and the fact that you need to install a lot more cell sites and a lot more transport links to support them with ultra high capacity links. And it brings it into a unified solution to this exact massive growth challenge. So on one hand, you're looking at, what we call the fastest way to get ultra high capacity. Those are the enhanced E-band, the millimeter wave connectivity that Erez mentioned, along with, traditional wideband microwave. And sometimes we mix them together in multi-band solutions. And on the other hand, you have the routing part, the IP part, and that's where we came up with the disaggregated open routing. And this is really about, disaggregation, by definition is about separation into components. So in the recent years, there's a move towards disaggregation of routers. And it means that customers get the freedom to choose different solutions from different vendors depending on their particular requirements and mix and match them together. So that gives them, again, a lot of flexibility.
You use the term disaggregated router. For anyone who's not up to speed on what is a disaggregated router, I mean, you mentioned it's just you can put stuff in. Does this mean we're using white box routers?
Generally, when we are talking about disaggregation, is like the idea of how you are separating all the solution into components, and you are separating the networking hardware, and there is one part of the networking hardware, and there is another component of the networking software, and maybe there is another part which is actually gluing everything together with the wireless. So what we did us as Ceragon, we took all of our experience and expertise in the wireless transport and the space, and we applied it into the routing space. And by this, we, in the past 20 years, were listening to most of our customers' complaints and their challenges. And we came into an approach that disaggregated routing solution will be the easiest and the most efficient to our customers. So what it means? Yes, you spoke about white boxes. Yes, we can implement our solution with white boxes, but we also have our own in-house hardware box that our operator can use. We have an open software. This is another separated component. So it's the free to choose for the operators. Do you want to choose your hardware? No problem. We can bring our software and we can do the integration all together. Do you want to use our hardware, in-house hardware, with our in-house software? It can be done as well. By the way, do you have wireless in your network and you want that the router will be connected to the radios? We have the glue. We have the radio where open networking, and this is a third component that we can combine all together. So in the end, it's like a Lego, and we are bringing back the power to the operators to choose which hardware you want, which software you want. Are you using it all a standalone router? Are you connected it into wireless? We can do all together. So this is more or less the idea.
What's the benefit of having your software, the glue, compared to just using someone else's router that they've already been using for a long time?
When you're connecting a wireless radio towards a router, not always the router knows exactly what's going on within the radio. So if there is a degradation and the capacity that the radio can carry because of a lot of weather problems or any kind of interference, the router will not know about it. So assuming that you have a radio that can transfer 1 gig and now it has a degradation to 500 meg, the router will still continue to send 1 gig towards the radio, and 500 meg will drop immediately only on the entrance of the radio. But if you will have a glue that or something, a kind of a magic that will tell the router, listen, it's not 1 gig anymore, it's 500 meg. So the router knows how, he will know how to act. He will send only 500, or he will do a reroute towards the alternate path to transfer the 1 gig. And this is the idea. The idea is to take all our expertise and experience from the radio, all our knowledge from the radio, and share it and actually expose it to the router. So he will do the actual and the appropriate actions, which is benefit to the entire network. And we're talking here about network efficiency. In the end, you want that you will be use the network as much as possible, and you want that the end customer will have what we are calling quality of experience within this network. So we don't want to see kind of disruption with everything that is doing.
So your glue is radio aware. It knows what's there.
Yeah.
And so your software layer of that routing can be applied either on your own hardware, white boxes, or anyone else's hardware as well?
Yeah, it's a great one because this is something that pops up for most of our customers. So we are not going to change the word and going to the operator and say, look, all the routers that you have right now, just remove them and put ours. No, we are saying we are going to leverage your existing install base. If you have currently a router and you are using the microwaves, we can be just the glue in between. If you want a full turnkey solution, we can do it. We can give you the hardware, the software, and the glue. But the radio aware is a Docker that can be implemented in each and every router. And by this, you are giving the existing router all the capabilities and all the knowledge that he needs to know what's going on within the radios.
Is that based on the max capacity or current capacity or some combination? I mean, when you're configuring that little glue that to make it radio aware, you're setting the max first of what the radio link can do. And then how does it know that, I guess that's your secret sauce. How does it know what the current status of that radio is?
Well, we know how to know like every second what's the actual capacity and what's the max capacity that the radio can carry. So we can really transform it and to bring like a bandwidth notification towards the routers, and by this it will be solved. But it's not just about what's the capacity about the radio. One router can carry many wireless radios, and each radio, such of radio, needs to have an external IP address. The idea of this radio aware is also to eliminate the need for a lot of external IP address. So it's also a single point to all the radios connected. So it's a single IP address. It gives you the actual throughput that the radio can carry, and it manages all the radios in one place. So you have a component that really controls the radios, connect it with the routers, and it's like a virtual indoor unit for those who knows what it's split mount. It's like a virtual indoor unit for all the radios connected to the routers.
It's aggregating radios together and routing them.
Aggregating radios together from the essence of managing them. Yeah, it can manage all of them together from a single point. It can control them having a single IP, external IP, and then all the radios that connected are the IP are internals and are not exposed to the network. And it tells to the router what exactly the bandwidth that each of the radio can carry.
Great. Can you give us a real world example? What's a scenario that someone might have implemented this process, and how did it work out for them?
So there are several use cases that I can think of. Maybe the first one related to the last question that you asked. We have a tier one operator in Europe that really has already installed its own white box, and now he's in touch with us, and we are working on integrating our radio well within these boxes. So I can give you, this is the first one. They were really impressed about the way that how their network become much more efficient while you are installing the radio well. And maybe we have another really nice use case that I can think of where we were asked to build the next generation 5G network. And the idea was that we will do all the transport. We will have the DCSG, the disaggregated cellular gateway, but also the aggregated routers. And all of this, what we suggested is our solution. We have our own routers, as said, but also for the aggregation router, we used the open box, and then we put our software on top of it. And this network was built in a way that it was a very challenging place in Bermuda with a lot of interference, and still we were using wireless because this was the only way to implement it. And these radios were connected to our routers on the edge side with the DCSGs, and on the aggregation point with the bigger routers. But also these big routers were implemented radio aware and our own network operation system.
You'd mentioned something earlier, which I liked, that you might put in a radio solution temporarily until the fiber gets pulled. We all love fiber, then copper, then radio is like the third choice. But sometimes it's the choice you have. If you put in your disaggregated routers with your radio aware glue and they replace that link with fiber, is there still a benefit there?
In the end, you will not use the wireless radio. Still, you have a state-of-the-art radio router. And these routers, I don't know if we mentioned, what Ceragon is doing is we are cooperating with IPM Fusion. And IPM Fusion is the best network operations, layer 3 network operation system in the market. And by having this, it means that we have the full set of the layer 3 capabilities within our own radio. It means that we know how to implement any feature needed, and mainly specifically for the 5G. When you're talking about 5G, and we talked about the challenges, there are a lot of services that needs to be deployed, and you need to have much more capacity. You need to reduce the latency, and there will be much more cell site. And in the end, you have your own physical network, but you need to slice it logically into different slices to support different services. For example, you need a lot of bandwidth, for example, the EMBB, so you don't care about whether the latency will be big or low. You don't care about the latency. But if you're talking, for example, on V2X, vehicle to any, IoTs or drones or this kind of services, then the latency is very critical, very critical. And therefore, you need to slice the physical network into logical slices. The way to do it is with segment routing. And segment routing is a very powerful feature within the layer 3. And using the segment routing is giving you two things. One, it simplifies the layer 3 network because you don't need several protocols such as LDP or as RSVP to carry the labeling of the MPLS. But the second thing is that segment routing gives you the option to do the network slicing. And this is something that we implemented within our own routers. So you have a very cost-effective router box that can be used for the wireless radios, but it can also be a standalone router to any kind of any choice. So if the fibers will be there, they will be connected to the routers without the need for the wireless.
Well, good. You'd mentioned disaggregated routers. I'd heard that this is a TIP standard.
Yeah, a few years back, there is a community called Telecom Infra Project, also known as TIP. And we are members of the Telecom Infra Project, the TIP. We are contributing there. We are the first one to add the radio aware. You can find a lot of information about what we are doing with the radio aware as well. And our own router was designed and built according to the specification of the TIP. And we are the only vendor that got recognitions from the TIP for our radios, for our networking software, and for our networking hardware. So when you are looking at all the three components that we discussed about the disaggregation, we got the recognitions from Telecom Infra Project, and we are contributing there, and we are very pleased with all the work that we are doing with them.
Well, Danny, can you fill us in a little bit? How would customers get information about this disaggregated router, and where do you see the market for that entire thing going?
So, the research from research companies show that disaggregated routers and DCSGs, they already accounted for around 10% of cellular gateways already back in 2021. And the projection, and it's moving forward, so the projection is by 2024, which is next year, almost 25% of all cellular routers are going to be disaggregated. So in other words, disaggregated routers are here to stay. They're getting traction. Now, we also wanted to hear it firsthand from our customers and potential customers. So we recently conducted a survey among hundreds of service providers. And all those people were either CTOs or network engineering or operations people. And we asked them about disaggregated routing. And what we found out, the results were that 70% of them were familiar with disaggregated routers. And out of those, 60% were already evaluating or actively deploying disaggregated routers in part of the network. Now, we also asked them about their top motivations for doing that. And we found out that flexibility, and we talked about flexibility, was the number one reason. Because they get the freedom to choose different solutions from different vendors, depending on their particular requirements, and they can mix and match them together. The number two reason that they noted was reduction in cost, especially reduction in capital expenses, which really resonates with with a special kind of DOR that we talked about, the radio aware DOR, which is kind of like a 2-in-1 solution, a faceless router and an indoor unit for the radios. And then the number three reason was the ability to launch new services and increase revenue. And it relates to the fact that with open routers, they have more leverage when they want these vendors to build a solution that addresses their specific needs.
Thanks for your explanation. Great. Well, thanks for sharing this information about not only disaggregated routers, but how you're putting the whole thing that's radio aware together. If someone wanted to follow up with you, Danny or Erez, where would they track you down?
First of all, you can find us on Ceragon.com. And over there, we have a blog, a very active one, where we post on a weekly basis new stuff. You can find Erez and myself on LinkedIn and approach us directly over there. And there are several white papers that you can check out on our website on DCSG and disaggregated routing, E-band, and so on.
Well, thank you. We'll definitely put in the show notes links to both your LinkedIn as well as your white papers. I read a bunch of those. Great information there to learn how it's working. Well, thanks for your time today. You can find this and many more fine free technical podcasts along with community blog at packetpushers.net. You can follow us at Twitter at packetpushers, find us on LinkedIn, and hear us on Spotify, and make sure to rate us on Apple Podcasts. Again, this has been Heavy Wireless, and look forward to seeing you in the next episode.